Hello, and welcome back to my weekly vlog. For those of you who have been following my journey in building PyFlow Studio, which has sort of become an obsession of mine at the moment, you probably saw how I was just getting to grips with some of the technologies involved in building the app, and I was just getting started on building the app itself. So this week, I believe I have moved on a bit and have actually managed to get the app talking to my Pi. Considering you all have been interested in seeing what is happening, I thought I would do a bit of a demonstration of the current state of the app. So let's begin. So for this week, I have set up a physical computing experiment, as you can see on the left of the screen, and you can see it here. The experiment is fairly simple. It's got two lights, these, and a motor, and a switch, which will allow me to control the fan. So the goal of the experiment was to showcase how I can use code to detect when someone presses the button, so the fan can be switched on. And in parallel, I also want the lights to indicate whether the fan has actually been switched on or not. So red to indicate the fan is off, green to indicate the fan is on. I will be pressing the button once to turn on the fan and a second time to turn it off. Now, we don't have any code written to do any of the above yet. So as you can see, it's actually not doing anything when I press the button on or off. And we are going to write the code today as a demo to see how very power platformish the whole thing can be if you use PyFlow Studio. So the app has changed a bit from last week. I have added a few features to the variables list. As a maker, you can create a constant and a variable now. A constant sort of indicates that the value of that particular variable will not change. Your formulas cannot change them either when they are running. So here you can see I have defined the pin numbers as as constants. Now pin numbers are indicate the number of the pin on Raspberry Pi to which some of the components are connected. So because naturally I don't expect to change the wiring in the middle of the experiment. Whereas I have defined a variable to indicate when the fan is on or off, which is obviously will need to change when we press the button in the circuit when it's running. Oh, apart from the changes to the variables side of things, I've also managed to make some changes to the flows side of things last week as well. So I remember I didn't quite define what I mean by a flow in this particular app last week either. So think of a flow as a piece of code that is run when something happens in the app or in your Pi. For example, when someone presses a button or the app starts up for the first time. Um, the three types of flows that is supported in the app are the on start flow, which behaves like app on start in Canvas app. So it is run once when the server starts up. You can use this to set up the state of Pi for other flows. For example, switch on a particular light or switch off a particular light. The other type of flow is a schedule flow. It works very similar to how recurring schedule works in Power Automate. Now, this is when you need to run some formula in a scheduled manner, like once in 5 seconds or once in 3 days, and so on. The third type of flow is the pin level change flow. In electronic circuits, pin level changes are the simplest way in which we can indicate an event is happening. For example, someone presses a button or some alarm is triggered somewhere. Now this type of flow will allow you to wait for an event happening on a pin and react to it. Now imagine you want to switch on a light when your camera detects someone walking through, or when someone presses a button, you would like to send a message out to the external world. So all of this can be done with the pin level change flow or edge level change flow. So now that we have gone through the changes that have happened in the last week, Let's finish the experiment that we started off. So once again, to repeat, the goal of the experiment is to allow the 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 fan here to be controlled by that button. Now, when the fan is switched on, we want the green light to be on. Otherwise, we want the red light to be on. Initially, we want the red light to be on, obviously, because of the fact that the fan is not on. So we will start with that. So let's start with an on start flow. So we will say right pin. Now, you may be confused with this particular the particular function that I'm using. Now, bear in mind that this function is not available in your regular Canvas apps, Canvas App Studio. The reason is that this particular function has been written as a customization to the PowerFx library. The PowerFx library that Microsoft have released as in an open source manner. So what I have done is I have had to download the library and make some changes so that I can write my own functions on top of that. So write pin and read pin, and there will be other functions as well in the future, will allow you to interface with Raspberry Pi simply using PowerFX. So let's start with that. We know that the green light pin is that one. I'm going to set the pin level to low because I want it to switch off, and I want the red pin to be switched on. Pin level is high, right? So that's it. So let's publish it. The moment you publish it, you'll see that the flow has started running because it switched off the green light. Now that's good. Now let's go to the next one. So remember when I said that the pin level change flow is the one that will allow you to react to changes happening in Raspberry Pi, for example, like someone switching the button off. So so this is what we are going to use to detect when someone has toggled the button. So when the toggle button is pressed. Now I know for a fact that the toggle button is connected to pin 25. The edge is falling. Now don't worry too much about what that falling actually means. Think about it as a way to detect a level change or a flow of electricity change in that particular pin. So what I need to do is the first thing I need to do is to toggle the fan, because I know that the fan toggled at is initialized to false in the first instance to indicate that the fan is not switched on. Otherwise, it'll toggle it back again. So this is how we will detect that the fan the fan needs to be switched on or switched off. So I'm going to check whether the fan is switched off. If it is fan is switched on, or someone has pressed the button to indicate that the fan needs to be switched on. If it is so, then I'm going to basically let the fan pin know that we want it switched on. The second thing, or if it is switched off, then I would like the fan pin to also switch off. So that should do it. So let's publish this and see what's going on. Right, so the app should now run. Let's see what happens when I press the button. Brilliant. That's brilliant. Now I press the button again. The fan is switched off. Now, do you remember the goal? One of the goals was obviously to switch on the fan and switch off switch on the fan and switch off the fan based on the button press. The other one is we want to indicate through the light as well. So we will write some more code here. So you're basically going to go right pin. When the fan is switched off, we want the green light pin to be on and the red light pin to be off. Excellent. And the fan obviously should be switched on as well. Similarly, when the fan is switched off, we want the red light pin to be high and the green light pin to be. Oh, right. So we have made the changes. Let's publish that and see what's going on. Right. So we have switched it on. Let's see what if it works. That's great. Brilliant. Right. So now you saw, now we can see how, so using simple PowerFx and, citizen dev tools, you using, a browser, much like how you would use Power Apps, we can actually control uh, IoT devices like the Raspberry Pi. Now, in the future, in the next few weeks, I'll continue to improve upon this. I will probably be doing a bit more hardware centric programming. So I'll keep you posted on that. Until then, see you.